Welcome to the Circles Formative Review. So we're going to be solving 5 problems on this review that are very similar to the problems you'll see on the formative. We'll be looking at inscribed angles. We'll be looking at angles formed by tangents. We'll be looking at angles inside the circle and angles outside the circle. Here's our first problem. We want to find the measure of x. Now, if we look at this arc, here's our arc, right? Here's the endpoints of our arc, and we follow it back. And so notice that arc there intersects this angle. And so if we follow the angle back to the vertex, we see this is the inscribed angle for the intercepted arc, for that red intercepted arc. So we need to know how much that angle is. Well, if you notice, that angle is part of a triangle. All right, let's call it angle 1. All right, so together, actually maybe I'll write it over here. Angle 1. Together, angle 1 plus 38 degrees plus 61 degrees equals 180 degrees. This is just using triangle sum theorem. So remember that the angles in a triangle add up to 180 degrees. I'll write that in there. So angles in a triangle add to 180 degrees. All right, since we know 2 of the angles in the triangle, all right, if we just add the third one in, right, and set that equal to 180, we can find the measure of that third angle. So angle 1 plus, let's combine the other 2 angles, so that would be 99 degrees. All right, so subtract 99 from both sides, and we get that angle 1. Actually, I'm going to write in subtract angle. Subtract 99. We get that angle 1 is equal to 81 degrees. Right? So 81 degrees is this missing angle. Now that we know the angle, we can find the arc. So if you remember, so this was the first part. This was step 1. Step 1, we had to find the measure of, excuse me, that's the problem there. Step 1 was we had to find the measure of the angle, right? Because that's the inscribed angle for that intercepted arc. Step 2, we need to find the arc. Remember that the arc is going to be equal to twice the inscribed angle. So if, and the arc there is x, if the angle is 81 degrees, that means that the arc is going to be 162 degrees. And there we go. All right, so there's our first problem. We found it. All right, so x is equal to 162 degrees. So if you have a problem that involves a triangle and you know 2 angles, find the third angle. And remember that the intercepted arc is twice the inscribed angle. Let's look at the next problem. All right, now this one, we want to, I forgot to write the question here. We want to solve for the measure of angle 1, angle 2, and angle 3. The most important thing is to do one problem at a time. It doesn't really matter which one you start with. It doesn't matter if you start with angle 1, angle 2, or angle 3. Maybe we'll start with angle 1 just because that was the most recent thing we've learned. So angle 1 is an angle outside the triangle. By the way, feel free to take notes on this. Now I'm going to write the word notes. So it's an angle outside the circle. Excuse me. All right, so you can use the notes however you like. So feel free to take notes if you want. So an angle outside the circle, remember, is equal to, so angle 1 is going to be equal to 1/2 large arc minus small arc. Now if we just trace, now I oriented the board, but it still doesn't mean it's very oriented. If we trace our angle, we see that the two arcs that are intercepted by that angle, right, they're inside the angle there, those are a large arc and small arc. Now obviously the large arc is the one that's farther away and has a larger measure, and the small arc is closer to the angle and it has a smaller measure. So angle 1 is equal to 1/2. The large arc is 88, the small arc is 40. So angle 1 is 1/2 of 44, or 22 degrees. All right, so those are just like the problems we've just been doing, right? You just have to ignore everything else and just focus on angle 1. Now let's just focus on angle 2. All right, so look where angle 2 is. Angle 2 is created by these two intersecting chords. Notice that it is inside the circle, but it is not at the center. Right, so it is not congruent to the arc. Obviously it's not congruent to the arc because if it were, those two arcs would be exactly the same, and they're not. These two angles are congruent because they're vertical angles. So those two angles can't be congruent and then one be equal to 26 degrees and another one be equal to 88 degrees, right? That one doesn't make any sense, right? Congruent means that all four of them have to be the same. So the angles are not congruent to the arcs, but what they are equal to is the average of the arcs, right? So when you have an angle that's inside the circle, it's equal to the average of the two intercepted arcs. So angle 2, I'll have to do it up here because I wrote kind of big. Angle 2 is equal to half first intercepted arc plus the second intercepted arc. We add the arcs on this one. Right? We're taking the average of them. Right? So angle 2 is not as big as 88 degrees. It's not as small as 26 degrees. It's right in the middle. So we need to take the average. So angle 2 is equal to 1/2 of 26 plus 88. So that means that angle 2 is 1/2. Oh, and I should write this. This is an angle inside the circle. Just to distinguish between them. All right, so angle 2 is equal to 1/2 26 plus 88. So angle 2 is 1/2 of 114. And that means angle 2 is going to be 57 degrees. So we found angle 2. We took the average of the arcs. We found angle 1. We took the difference of the arcs, right, because it's outside the circle, large arc minus small arc. We have one more to do, right, and I could really use another color. I guess I'll use green. All right, we have angle 3. Now, if you just focus on the sides of angle 3, all right, you'll see that angle 3 is an inscribed angle. And an inscribed angle is equal to half the arc. Now we have to figure out the arc. Right? So now if we look at the two endpoints of the, I guess I'll write in black. If we look at the two endpoints of our angle, we have one endpoint there and one endpoint here. That's where the angle intersects the circle. The arc that's between, oh boy, what a nice glitch there. The arc that's between those two endpoints, and maybe I can, are the two arcs that are measured to be 26 degrees and 40 degrees. And let's see if that looks a little better. Oh, that's not the same curvature. There's just no hope. Nope, no hope. We'll have to have a crooked arc. So we'll leave the arc out. So it's the circle, the unbroken piece of the circle, that includes the 26-degree arc and the 40-degree arc. Together, both of these arcs combined are the intercepted arc for our inscribed angle. So angle 3 is equal to 1/2 of, we'll add them together, 26 plus 40 is 66. And that means angle 3 is 33 degrees. And there we found the measure of all three. And you notice that none of the angles needed the other ones, right? So angle 1 was its own problem, angle 2 was its own problem, angle 3 was its own problem. You just have to focus on that angle amongst everything else. Just see angle 1 and ignore everything else. Just see angle 2 and ignore everything else, and then just see angle 3 and ignore everything else. This was the hardest problem on this review, and it'll be the hardest problem on the formative, but if you just focus on one part at a time, I know you can do it. All right, this one's actually a pretty easy problem. We want to, and really just involves being able to solve an equation. As long as you set this up right, it's not a very hard problem. We want to find the value of x if the measure of arc ABC is 5x minus 16. Now, it doesn't matter if the angle is formed by a tangent and a chord or two chords. If the vertex is on the circle, it's an inscribed angle. Right? So the angle C, well, let's call it CAD. Angle CAD is an inscribed angle. And we know the angle is half the arc. So we just take our formula and we substitute the values that we have. The angle is 56 degrees. Oops, missing a C there. The arc is 5x minus 17. But I look at that and I go, uh-oh, I'm going to have to distribute 1/2 to the 5x and the 17, and neither of those are even numbers. So I'm going to have a harder problem to solve if I distribute that 1/2. But remember, there's two ways we can write this equation. So the angle is half the arc, or we could think of it as the arc is twice the angle. And this one is going to be a lot easier to solve, because I don't know about you, I'd rather multiply by 2 than have to divide by 2. Right? So now let's use that equation. Right? So unless if you're distributing to two even values, then it's fine to use the angle equals the arc. Angle equals half the arc, because it would be fine to distribute the 1/2. But if you have an odd number, then you're going to want to use the arc is twice the angle. Maybe we'll do two problems like this. I don't know. So the arc here is 5x minus 17. The angle is 56 degrees. All right, so we'll just multiply. 5x minus 17 equals 112. Add 17 to both sides. Oops, I'm sorry. I would wanted that to be 5x plus 17. I did not want to give you a weird number. All right, so let us make that 5x plus 17. My problem, my prerogative. Just pretend it said 5x plus 17, because that's what I originally had. And then I was just adjusting the numbers, and then I accidentally must have wrote 5x minus 17 because I wanted something that was going to give you a pretty number, a nice little integer. All right, so now if we subtract 17 from both sides, we have 5x equals, that's going to be 95, and 95 is divisible. Oops. I need just a tad more space here. We'll put it over here. 95 is divisible by 5. If we divide both sides by 5, x is equal to 9 divided by 5 is 1 with 4 leftovers. 45 divided by 5 is 19. So x equals 19 is our answer. Right? And let's do this problem one more time, but I'm going to change the values, just to show you one where maybe you would want to, maybe you could distribute if you wanted to. All right, so this will still be. All right, and all right, we'll keep the 56. It's kind of nicely put in there. And let's just say, so find the value of x if angle, or excuse me, if the measure of arc ABC is 4x minus, I don't know if it's going to go in evenly though. All right, it'll be all right. 4x minus 16. All right, so now if we set it up, angle equals half the arc, or arc equals 2 times the angle. We could solve it this way. We could say 4x minus 16 equals 56 times 2. Or we could set it up as 56 equals 1/2 4x minus 16. This time we won't get a fraction when we distribute the 1/2, so this time it doesn't matter. So if you have two even numbers, it doesn't matter if you set it up angle equals 1/2 the arc or arc equals twice the angle. If you have an odd number, it'll be a little easier for you if you set it up as arc equals twice the angle. And I'll show you here, we're going to get the same answer. So I don't know if it's going to go in evenly, but it is divisible by 2. So 56 equals, so if I distribute the 1/2, I've got 2x minus 8. Oh, and this will go in nice and evenly. All right, so now we add 8 to both sides. So this would be 64 equals 2x, and 32 equals x. Right? If I solve this one, I have 4x minus 16 equals 112. We'll add 16 to both sides. So 4x equals 128. And if I divide 128 by 4, I get x equals 32. So you see we get the same answer either way. All right? So if you have two even numbers, you can pick it. Angle equals half the arc, or arc equals twice the angle. If you have either one of those is odd, it will be easier if you solve it arc equals twice the angle. All right, this was a nice example. Oops, I guess I erased the first one. All right, this one's number 4. So BC is a tangent to circle A. What's the measure of x? Remember that tangents are perpendicular to radii. This is circle A. This is the center of the circle. And that means that AB is a radii. So if BC if BC is a tangent, it means BC is perpendicular to AB. And we know that perpendicular lines meet at right angles. So that means this is a right angle. Right, so now we know two angles in a triangle. We can just use triangle sum theorem. I need to learn to write smaller. So use triangle sum theorem to solve for the third angle. Right, so we have 90 plus 47 plus x equals 180. 90 plus 47 is 137. If we subtract 137 from both sides, we have x equals, so that's going to be 43 degrees. And that's the measure of x. Right, so here it wasn't a very difficult problem to solve. You just had to remember that radii and tangents are perpendicular. That's a right angle, and then just add your angles up and set them equal to 180 and solve. Right? So that's two problems that involve triangles. This is our last problem. And this is just this one. We're going to end with the easiest problem of all. Right? Because this is just an angle that is formed. I probably should have made these stay inside the circle, but this is just an angle that's formed by two chords inside the circle. And we know we have an angle inside the circle that's not at the center of the circle. We know that the angle equals 1/2 the sum of the two arcs. So we're ending with the easiest one. That means x is equal to 1/2 of 95 plus 43. So x equals 1/2 of 138. And now just divide 138 by 2. So that's going to be 69 degrees. And that's it. We're done. Thanks for watching. I hope this helps you on your formative, and let me know if you have any questions. Bye for now.